Lesson 10, Unity Shaders. Hello fellow game designers, welcome to the Wicked Cat Unity Introduction course. After studying the normal and transparent shader families, we will now move to the transparent cutout shader family. Step 3, Transparent Cutout Shader Family. On this shader family we include Transparent Cutout Vertexlit, Transparent Cutout Diffuse, Transparent Cutout Specular, Transparent Cutout Bumped, Transparent Cutout Bump Specular. These shaders are used for specific objects where you have fully opaque and fully transparent parts, for example, chain fences, trees, or grass. The differences between cutout and regular transparent shaders are: cutout cannot have partially transparent areas. Everything will be either fully opaque or fully transparent. Objects using cutout can cast and receive shadows. The graphical sorting problems normally associated with transparent shaders do not occur when using cutout shaders. These shaders use an alpha channel contained in the base texture to determine the transparent areas. If the alpha contains a blend between transparent and opaque areas, you can manually determine the cutoff point for the areas that will be shown. To use the transparent cutout vertexlit shader, you will need one base texture with alpha channel for transparency map. All light shining on this shader is rendered in a single pass and calculated at vertices only. This shader won't display any pixel-based rendering effects, such as light cookies, normal mapping, or shadows. Next, on the transparent cutout diffuse shader, you need one base texture with alpha channel for transparency map. Diffuse computes a simple lighting model. The lighting on the surface decreases as the angle between it and the light decreases. The lighting depends only on this angle, and does not change when the camera moves or rotates. To use the transparent cutout specular shader, you will need a base texture with alpha channel for combined transparency map and specular map. Specular computes the same simple lighting as diffuse, plus a viewer-dependent specular highlight. This highlight is dependent on surface angle, light angle, and viewing angle. You can control the level of blur for the highlight with the shininess slider in the inspector. Additionally, the alpha channel of the main texture acts as a specular map, defining which areas of the object are more reflective than others. Black areas of the alpha will be zero specular reflection, while white areas will be full specular reflection. For transparent cutout bumped shader, you will need to have a base texture with alpha channel for transparency map, and a normal map with no alpha channel required. Like the diffuse shader, this computes the same simple lighting model. The normal mapping simulates small surface details using a texture, instead of spending more polygons to actually carve out details. The normal map effectively overrides the mesh's geometry when calculating lighting for the object. Finally, for the transparent cutout bump specular, you will need a base texture with alpha channel for combined transparency map and specular map, plus a normal map with no alpha channel required. This shader is very similar to the last one, but adds the specular to the material. Specular computes the same simple lighting as diffuse, plus a viewer-dependent specular highlight. This highlight is dependent on surface angle, light angle, and viewing angle. You can control the level of blur for the highlight with the shininess slider in the inspector. This was our third video on Unity 3D shader families. On the next video we will start by taking a closer look at the self-illuminated shader family. If you enjoyed this tutorial, please don't forget to leave a like on the video and subscribe to our channel. If you have any doubts or feedback, leave it on the comment section below. Until next time, and keep doing awesome games.